Students, in this video we are going to discuss about a problem which is in your activity sheet. See, the problem is the distance between 2 points A and B. So a distance between 2 points A and B is recorded as 28.650 meter at a tension. So when they are measuring the distance, the tension applied to the chain is 120 newtons and the temperature is 60 degrees centigrade. So the A and B are at different levels. The difference between the A and B is 0.48 meter. So here we used 30 meter tape. So generally this 30 meter tape is an actual used tape in the field, but one it is checked for its accuracy. It came to know that as 30.009 meter is the actual length. So when they measured this actual, when they find this actual length at a tension of 50 newton and at temperature of 50 degrees centigrade, and the area of tape is 4 mm square. So this standardization means it is a process to be done to find out whether the tape is having the exact length or due to any source of error, is there any change in length or not. So here we found that there is a change in length of 0.009 meter. Here you are required to calculate the horizontal length between A and B, assuming Young's modulus of steel as 200 kilonewton per 200 kilonewton mm power minus 2 means 200 kilonewton per mm square, and the coefficient of thermal expansion as 0.000112 per degree centigrade. So I'll explain this problem on the board. So let's go to this another part of the video which I explained all the problem on the board. So in this distances chapter we have a problem to determine the distance between A and B. So if you measure, the A point is here and the B point is here, it is in above this A point of 0.48 meter. The slope length, when you measure on this, the length is measured as 28.650 meter. Now here we are required to determine the horizontal distance between A and B. The horizontal distance between means in this way. So what is the distance between this A and B? So I'll explain you this brief what is there in the problem. The measured length is 28.65 meter. The difference between the heights of A and point A and B is 0.48 meter. So this field, when they are measuring these distances with tape, the tension applied was 120 newtons and the temperature in the field was 60 degrees centigrade. When the tape was standardized, they found the tape was, the original length of the tape is 30 meter, but when they standardized it, they came to know the tape is 30.009 meter. That means 0.009 meters more than the actual length. So when they standardized the tension, TS means tension at standardized time, it is 15 newtons. The temperature at the time of standardization is 50 degrees centigrade and the area of the tape is 4 mm square. So the Young's modulus of the tape is 200 kilonewton mm square and the expansion of thermal coefficient is 0.0000112 per degree centigrade. So this is the solution where you should find how to determine the distance between A and B. So now our theme is to calculate the horizontal distance between A and B. To determine the horizontal distance, we should check all these corrections before it. So we are having 4 types of corrections: slope correction, standardization correction, and tension correction, temperature correction. It is slope correction. We have a formula delta H square by 2L, where delta H is the level between the point A and B, where you know this, the level between the A and B is 0.48 meter. So in this slope correction it will be minus 0.48 square over 2 into the length is the measured length, it is 28.65 meter. So 2 into 28.65 meter. So if you solve this, you will get the answer 4.08 over 10 power minus 3 meter. So this is for slope correction. Now coming to standardization correction, the formula is capital L over L dash minus L by L, where here L dash is equal to the standardization length and small l is equal to the original length 30 meter. So if you calculate this, where capital L is 28.65 over 30.009 minus 30 over 30 in meters. So if you solve this, you will get 8.59 multiplied by 10 power minus 3 meter. So here I calculated the slope correction. This is for slope correction and this is for standardization correction. So now when you are calculating this tension correction, you have a formula, this tension in field, tension when standardized. So you have given the values of tension in field and tension when standardized. Here again the length is 28.65. The tension in field according to the problem is 120 and tension when standardized is 50. Over here A is area. So the area of the tape is given as 4 mm square and Young's modulus is given as 200 kilonewton per mm square. So here I convert 200 kilonewtons into Newton. So now if you solve this, 2.5 into 10 power minus 3 meter. So here this is tension correction. So when you want to calculate the temperature correction, so you have alpha, so temperature correction is equal to alpha into L into TF minus TS. So where TF is temperature in field, temperature when standardized. So alpha is 0.0000112, L is as usual 28.65, temperature in field is given as 60 degrees centigrade and temperature when standardized is 50. So if you solve this, you will get 3.2 into 10 power minus 3 meter. So from this you have calculated all the corrections, slope correction, standardization correction, tension correction and temperature correction. So when you are determining the horizontal distance, you have to use this formula. L is length, slope correction, standardization correction, tension correction, temperature correction and sag. So whenever you are calculating, if you get standardization correction as positive, take positive, where when it comes negative, take negative. It is same for everything. If when you are calculating, if it is negative, subtract from this. If it is positive, add to this. So in this condition, unless otherwise the weight and angle of slope is given, you have to calculate sag, but in this problem it is not given, so we are ignoring sag from this problem. So let's see how to calculate it. The original length is 28.65. The slope correction, I just change into the numericals, decimals, 0.00408 plus the standardization correction 0.00859 and the tension correction 0.0025 and the temperature correction 0.0032. So once you solve this, you will get 28.660 meter. So the horizontal distance after this corrections is 28.660 meter. So if you want to calculate the error, the original actual measured length is 28.65. So from this when you calculate, you got 28.660. So here the error is 0.01 meter. So this is the way how to calculate the horizontal distance. So from the problem, the horizontal distance determined, the actual horizontal distance is 28.660, but the measured one is 28.65, so the error is 0.01 meter.